Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so you should check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode to get a $20 credit and launch a new server in under a minute. And for complete visibility into the health of your pipeline, including deployment tracking and powerful alerting driven by machine learning, Datadog has got you covered. With their monitoring, metrics, and log collection agent, including extensive integrations and distributed tracing, you'll have everything you need to find and fix performance bottlenecks in no time. Go to dataengineeringpodcast.com/Datadog today to start your free 14-day trial and get a sweet new t-shirt. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. Your host is Tobias Macy, and today I'm interviewing Pete Cheslock and Pat Cable about the data infrastructure and security controls at ThreatStack. So, Pete, could you start by introducing yourself?
Yeah, hello. I am Pete Cheslock, and I currently run the technical operations for ThreatStack.
And Pat, how about yourself?
Yeah, I'm Patrick Cable. I do a little bit of everything. So I do security operations and all the sec DevOpsy things here at ThreatStack.
I thought it was DevOps Sec.
Who knows?
Sec. We're still figuring that one out.
I think everyone's still figuring that one out.
Valid point.
And Pete, going back to you, how did you first get involved in the area of data management?
I guess by accident, really. The sheer fact of joining ThreatStack almost 4 years ago in kind of the type of data and everything that we store, we keep a lot of data, we process a lot of data. It's definitely the most that I've kind of dealt with, I think at this point, at least by sheer kind of event count. But a previous company I was at, a company called Sonian, we were an email archiving company, and if you think like email archiving, the number of kind of events like emails would be a lot less than kind of a security event. But the amount of data emails take up, if you think like PDF attachments and other things, were petabytes. So we were storing a significant more amount of data then, just not as many kind of individual items as we do today. Different types of scale, I guess.
And Pat, how about you? How did you get involved in the area of data management?
Strictly along the ride here at ThreatStack, right? So one of the things that I care about is security time series data, right? So seeing when stuff happens on servers, and that actually kind of dovetails nicely into what ThreatStack does, right? So we capture system calls and other data about your EC2 and actually just not just EC2, but any infrastructure, running our agent. I'm kind of along for the ride when it comes to data management because I have to make sure that we're securing all of it properly.
And so, as you mentioned, ThreatStack is a platform and service for being able to capture event data within an infrastructure and your network environment for being able to analyze that for intrusion detection. And I'm wondering if you can provide some compare and contrast between the system and offerings that ThreatStack provides versus what the existing landscape was at the time when it was first started in terms of either open source or hosted options for doing the same kind of analysis of determining what threats might be present within an infrastructure or network environment.
Yeah, so one of the big things that I think differentiates us is a lot of the existing solutions would focus on logs, right? Somebody decided to log out some information, and there are existing solutions that will collect and aggregate all that log data, and all that log data is really good stuff, right? It's really important. You want to be capturing that log data. But the thing that always kind of fell short for me for log data was, what about stuff that I'm not logging, but I want to know what's happening on the system? What is somebody logging into the server and actually running and executing, right? So the thing that I found very exciting about ThreatStack was that we could do something like have an agent collect all the syscalls, which is, for folks that might not know what syscalls are, it's the base kernel actions for doing anything in Linux, right? So let's say that I run an application, I run a Ruby script, right? I'm going to be calling exec to Ruby, which is an action that I might care about. I'm going to be running open on the actual Ruby script itself, and so on and so forth. So our advantage, I think, is that we collect all of that system call data and all the parameters that go with it, and then can start constructing a timeline almost of what people are doing on these servers.
Yeah, from the open source component. So when I started here in 2014, and I was part of the kind of the pre-launch team, so really very early in the ThreatStack kind of timeline. The closest competitor was kind of open source concepts around Audit D. So in the very beginning, the ThreatStack product was kind of an Audit D replacement and cloud hosted. So we would have our own agent, which basically worked like Audit D, but much better. And we would collect, like Pat said, all of these system calls and ingest them into our platform, doing kind of analysis and determining what's going on, trying to answer that question of like who did what when. Of course, as we've grown over the last 4 years, we've added in a lot more features, which kind of blurs the line of like what other alternatives are out there, because we can do things like vulnerability assessment. We can integrate with Amazon specifically around CloudTrail. We can suck in those events and make sense of them. And doing other things like threat intelligence detection and really trying to, we use the word inform a lot. Trying to like inform our customers into anomalies in their environment.
Yeah. So the one that I think of is, you have a web server running and maybe it hasn't been patched in a while, and all of a sudden you see your web server process fork bash. Like, that's probably bad.
Yeah, I'd say that's not good. Maybe it makes a connection to like a IP in China too. Like that would be pretty bad.
Take your pick. So being able to kind of alert on those too, right? So there's like events, and we capture a lot of events. And then customers will write rules to bring those events to Sub 1, Sub 2, Sub 3.
And the focus seems to be largely around the hosts and the processes that are executing on those hosts. And I'm wondering whether ThreatStack has any overlap with tools such as Snort or Suricata, which are more for detecting inbound network connections, largely with a firewall-oriented perspective built into the way that the tool was originally designed, or whether tools like that really even make much sense in more modern cloud environments, or if those are more of an artifact of the data center-oriented infrastructure.
What's pretty funny is that the founders of ThreatStack actually created an open source project called Snorby, which was Snort, but like on Ruby on Rails. So it was like a Ruby on Rails tool for managing Snort kind of data. And even if you go back to the very early, kind of before I started, ThreatStack ideas that the founders had, the initial idea was kind of a place that people could pull in Suricata and Snort and other kind of intelligence data, I guess, in order to understand, what was going on in their environment. Only later, when they realized that the value really was in being able to kind of have an agent that can capture this data off the host directly and try to tie that in. That's when they really started going down that path. But to be honest, I can't really speak for some of those tools. I haven't used them in years at this point, and how they've kind of aged for the more, I don't know, we call it cloud native world, right? Where hosts are very ephemeral. They come and they go. You don't have the long-lived instances of yore for the most part.
One thing that strikes me is when you look at some of these network-based tools, it's interesting to see, host has connected to thing, but without the surrounding context of what's running on the machine, the next place an analyst is going to go is, okay, so let me figure out what on the machine made that connection.
Yeah, what was the process that was on that machine? Who ran that? What user ran that process?
Yeah. So it's interesting to me that these tools certainly serve a purpose, and I think they serve a bigger purpose when you have longer lived instances. And now when we're talking about cloud, instances may come and go. You might not necessarily know what was run on them. It's a little bit of a harder sell, I think, for those other tools.
And in terms of the types and structure of the data that you're collecting with your agents, I'm wondering if you can describe what the typical events would look like and what the flow is for when the event is captured on the host via the agent, all the way through to you storing and analyzing and potentially alerting on it.
Ooh, many pipelines.
Yeah, there's a lot of stuff to that one. I'll give it a shot here. So the type of data, like Pat was saying, are essentially Linux system calls, network connections, process connections. There's a few more things. We do something called file integrity monitoring, which is where we can put watches on kind of key files in your infrastructure, so that maybe like an SSL key or a configuration file that has like a database password in it. We can put a watch on those files, and then when a process accesses them, we'll be able to see which process accessed which file, like if you had a watch on it. So agent events, that's kind of one type of event we capture, and then CloudTrail events would be other ones. The nice thing about CloudTrail events is that they're pretty standard. People turn on CloudTrail for AWS, which is like an API auditing, for lack of a better term, of like your API usage on AWS. But on the agent side, at least, the data, that's what we consider to be much more real time. CloudTrail events that we consume, there's a delay that it takes for Amazon even to put the CloudTrail events in your S3 bucket. Once they're in the bucket, then they're in our infrastructure very quickly. But it's actually the agent events which poses the largest kind of technological challenge for us, because if you have, for every process, you could have hundreds or thousands or tens of thousands of syscalls associated with it, or every time maybe your process forks or opens a connection, there's multiple system calls associated. And so the ultimate goal in the very early days, and continues on to this day, of ThreatStack is to always be consuming this data, because they're all potentially security events, and to process it as fast as possible. At a high level, the agent will send this data into ThreatStack, and we run on Amazon Web Services. We're very big fans of using AWS, and the data comes into our environment, and of course the evolution of our platform has changed over time. At a real high level, in the past we used to use a lot more of RabbitMQ. So if you kind of rewind back to 2014 when I started, we were bringing in RabbitMQ essentially as a way to replace ZeroMQ, which was the original like messaging layer of kind of the ThreatStack platform. We ran into a lot of issues with ZeroMQ at the scale, even the scale we were at in the very early days. And so RabbitMQ at the time, myself and our CTO at the time, we had a lot of historical experience with RabbitMQ, and scaling RabbitMQ was something I wasn't really too worried about. So we decided to bring that in. A lot of times people are always saying, oh, well, why not Kafka? Well, 2014 was a different time. I don't even know what version Kafka was, but to be honest, I wasn't willing to bet a company on something that new. But again, fast forward to 2018, and now we have multiple Kafka clusters that we're actually bringing in place, that are replacing a lot of the pieces of kind of what we would call our old RabbitMQ infrastructure. But if you think of it like the data pipelines is kind of how we talk about it internally, data is essentially getting published to these Kafka topics, and then we can have lots of different processes or microservices, I think is the new fancy term.
That is the new fancy term.
So you have these microservices that are accessing all this data in Kafka, and then analyzing it and doing different roll-ups and things like that, using some tools like Spark. I think more recently we've been using tools like Flink for kind of rolling up data, or doing, I don't know if you'd call it like batch processing.
Yeah, roll-ups.
And then under the assumption, let's say one of these security events triggers an alert, then we can like tie into third-party services, and like Slack, for example, or HipChat, or even like PagerDuty. We could send a message to PagerDuty and alert you if, let's say, someone installs like a kernel module in your environment, which
that's not good.
Usually not a good thing.
Yeah. Unless you're doing embedded development, I guess, but
And there are a lot of different topics out of that we can go into. And to start with, I'm wondering, how you ensure that the event data that you're being delivered has a consistent format so that it's easy to manage that as it traverses your various pipelines, and so that you can ensure that you have the necessary information from source to destination.
Yeah, yeah. Our first step when we take this data in is to basically make sure that it matches our expectation for what this data is, right? So we have a service that its job is to figure out what is to make sure that the data is in the right format.
Yeah, I guess the best part about having our own agent versus like Audit D. A lot of times people said, "Oh, well, it sounds like a lot like Audit D." And at a really high level, many years ago, our agent looked similar to Audit D, except it was built to be much more performant. The biggest difference, though, especially in those early days, it's much different now because we're doing a lot more. But if you've ever looked at like Audit D log formats, it's like multi-line. It comes in out of order. It's just very difficult to parse in many ways. You'd have to correlate multiple log lines in order to get the full concept of an event, right? With our agent, we actually take this data and store it as a JSON object and store things like the process name, the port number,
right.
if it was a connection, right? Or like an IP address. And like Pat was saying, we'll have these services that can not only ensure that like the data is in the format we expect, but like also do kind of like data sanitization. We've ran into weird issues where the Linux kernel, like we just take what's coming off the Linux kernel. It's actually the audit APIs we interface with. But the Linux kernel is, I don't know, not great.
There's a lot of cooks in that kitchen.
There's a lot of cooks in that kitchen. That's a good way to put it. So we've seen scenarios where you might get a process ID that's completely out of range, or a negative number from the Linux kernel. And so, how do you deal with that, right? So we have to do some like data sanitization to make sure that like further on down other data pipelines, like we don't run into issues with that. Like expecting a process ID within some I guess normal range and have it come back to us as like for Unicode or something like that.
Yeah, or the source port, for example, making sure that it is actually a valid port from 0 to 65535 versus like -9.
Well, actually, and that leads me into a hilarious story of when we first launched we called it our limited availability. It was like the month before public availability launch. I was actually not there for that launch. My son was being born at the time. So I basically at like 4 a.m. went to the hospital with my wife and said, good luck. I'll see you in a couple weeks. And when they launched the limited availability, some data getting sent from an agent was completely malformed, and they had to track it down to find out what agent it was. Turned out actually to be my test agent that was running at the time on an IRC bouncer, and it was doing exactly like that, like what Pat said, which was it was sending like a port number of like, I don't know, 30 million or something, like some insane number that like, in no way is real.
It's like one of those IPv8 ports.
IPv8.
Yeah, I think we're in a very unique position to, like Pete said earlier, we do have our own agent. So it's not that we wouldn't do sanitization, because that scares me as a security person. It's just that we get to be more strict about what we accept in the first place, which is a nice place to be in.
And playing again off of your story of having to track down where the particular data was coming from, what mechanisms do you have in place to ensure the provenance of the data that you are collecting and ensure that the chain along which it's being delivered is verifiable so that you don't have anybody maliciously injecting false data into your system?
Yeah, so there's a lot there. A lot of the stuff around agent auth could be a whole nother podcast, but we do have a authentication structure within our agent that makes it so that both sides have to compute something to figure out what is the data is associated with that agent ID, and that's a big part. But also, as we go down and we build services out, security has been something that we've been part of our organization since the start, and we've only made more of a commitment to that as we've built out our security team. So we have a lot of work that goes into how do all these microservices talk to each other and ensure that the requesting organization and the requesting user makes sense for the data that's coming back. And so we do a lot of work in making that story and that performant. It's an important thing because obviously it would be a very bad thing if one user's data went to another user, right? That is a pretty big failure. And so we've put a lot of stuff in code to basically make sure that the requesting organization, the requesting user makes sense for the data that comes back, and we check it on the way back out too, which is kind of neat.
Yeah, I guess ensuring that the data coming from a series of agents. So if you think of it like associating, you have a customer, they'll have an organization. That's kind of a top level idea of ThreatStack, where you'll have an organization. What's actually very cool about how we've designed the product is that you might have maybe a large company with a lot of different organizations with different pieces of infrastructure. Let's just think at a very basic level, you might have a dev environment and a prod environment. The alerts and the rules that you define within the prod environment might actually be different than in dev, but maybe you run ThreatStack across both, which a lot of our customers do. And so you could kind of have one customer with multiple organizations. But we do a lot of interesting things on the encryption side as well to ensure that as data is landing in our environment, that it gets encrypted with kind of this like organizational key, not even like an account, like a customer specific one. It's really down to the organizational level. What's really interesting about that as well is that we can ensure that like once a customer's no longer with us, we can just shred keys as a way of removing any sort of access to that data.
Yeah.
And going deeper on the idea of having your agents deployed across multiple environments within a given organization, what types of contextual data or additional formatting or even rate limiting of the data do you provide to the end user for being able to manipulate how the information is generated and what additional context is contained within the events that get delivered?
Yeah, I mean, so we don't really focus on, we want to be able to capture all of those events, right? Because if there's too much control on the user side, it would be trivial for an adversary to go in and say like, great, don't send any events. Like,
we really we treat the kernel as the source of truth. So if it comes off the kernel, then the goal is to essentially get it to our infrastructure without modification.
Yeah. Now that said, there are ways in which, we can, if we know and a customer reaches out to us and says like, hey, this particular command is kind of sensitive, or like the inputs to this command will be sensitive, then that's something we work on a case-by-case basis. But
that's actually a really good point, which is, you might have a customer who says, I have some processes and, PCI related or something, and I don't know, like
HIPAA
you're passing,
is the one that comes to my mind, right? Like you're processing data in some sort of,
or like an argument,
and the argument is the patient name, right?
Yeah. So like, let's say you have a command that runs, we capture not only the command, but all the arguments associated with it. You'd want to know like what flags maybe were passed to a command, or if bin bash was executed with some other service, right? That would kind of be an argument. And so for some customers, they say, oh, well, the way that this application works is we pass essentially PII as the arguments. Say to us like, well, how do we ensure this data actually never leaves our environment? And so we actually have some kind of filtering technology on the agent side where customers could kind of define what is PII for their environment to kind of remove the likelihood of leaking kind of sensitive data.
Yeah, but that said, that's a very small amount of our customers. Most of our customers want that full visibility and just want everything coming off the kernel to show up in their interface.
Yeah, we often refer to it as a fire hose. It truly is a fire hose of data in many ways.
And with how much volume of data you're working with and the various different pieces of how that data is flowing through your system, how do you ensure an appropriate level of consistency and scalability in the actual underlying infrastructure that you're deploying and ensuring that the systems are operating as intended?
Yeah, that's a great question. there's an animated GIF that I use often when I talk about how to scale on the cloud, and it's a picture of I think it's from, I don't even know what cartoon it's from, but it's like the old lady from like Tweety Bird, I think, throwing money into a fire, just like money to her into the fire. And I use it often. So I guess one benefit of using the cloud is getting more cloud is usually not too hard. Of course, there's instance limits you have to watch out for, but if you have money, Amazon will happily take your money for more cloud. So that's obviously one big place. We scale up hundreds upon hundreds of nodes maybe to handle scale events, scale back down when we're done processing. But for the most part, the load as data is coming into our environment, we use probably our largest databases that we use are open source databases like Cassandra or Elasticsearch. Cassandra is great because it allows us to do quorum writes, which from a data durability standpoint, we can run across multiple availability zones or multiple regions to ensure kind of the durability of the data. So we won't acknowledge a write of data unless it has written to multiple Cassandra racks is the term, right? And so a rack for us might be like another AZ or another region. Elasticsearch is something similar where you can do fun things around kind of primary and replica shards, where you can say like a replica shard can't live in the same rack as a primary. So we essentially do the same thing. And that's been a big help. Kafka too as well. Actually, one of the biggest benefits of Kafka is that ability to do quorum writes, where you can not acknowledge a write into a Kafka cluster unless it has written to multiple, again, same idea, racks, availability zones, regions, things like that.
And on the subject of your migration from RabbitMQ to Kafka, I'm wondering what you have found to be the benefits, whether it's in terms of cost savings, either time or monetary, or simplification of the overall deployment or management of the actual infrastructure, or any other tertiary benefits.
Sweet durability.
Yeah. RabbitMQ, and I say this as someone I've been using RabbitMQ for, I don't know, almost a decade, for a very long time. So RabbitMQ is something I have a lot of comfort in running. If you actually rewind back to when I was at a company called Sonian, RabbitMQ was one of the core pieces of infrastructure, to the point that when we built out and open sourced Sensu, the monitoring platform, we used RabbitMQ for transport of essentially monitoring events. And if you are a Sensu user, RabbitMQ is still an option until the new version of Sensu comes out. And so when we brought on RabbitMQ initially, some of the challenges of RabbitMQ scale and durability comes to just how to do replicated queues. And they've done a lot of improvement around there, but it still kind of suffers from maybe the same idea as like Elasticsearch, where you don't have an idea of like quorum writes, where you can't ensure writes across multiple places, in the same way that services like Kafka and Cassandra do. And maybe that's the case. Maybe it's better now. Honestly, I haven't looked too recently at the more bleeding edge versions of RabbitMQ. For us, the main reason of moving it was essentially data durability. We wanted to have a higher degree of understanding that the writes into Kafka were secure. But one of the interesting parts around the original RabbitMQ architecture was the way in which we ensured that we could scale it. Is we basically created this concept of pods. And this is before Kubernetes was around. So we were like the hipsters, I guess, of the term pod. But we have an internal term of a pod, which is a RabbitMQ with a series of services kind of wrapped around it. And so those turn into our individual scale points, where if we need to run more scale through a single RabbitMQ, because there are going to be upper bounds just based on the size of the instance, we can basically duplicate these pods, and we could run 5 pods or 10 pods, and we can span these pods across availability zones as a way of essentially writing bits across multiple places. But the ultimate issues why we decided to move off of it was we were building out new infrastructure a couple of years ago, and it was essentially how we manage alerting our customers when a security event occurs. And you can imagine an alert sending an alert that a security event occurred or that a specific system call was a anomaly, sending that alert is of high priority. So, and the durability needs of that were, we need to be much greater than honestly we believe that we could have gotten out of RabbitMQ at the time. So that was a big reason to move there. Now, the benefits have been, it is significantly more performant than RabbitMQ for, again, our load type. We actually ran into a lot of issues, which, again, mostly just how we're using RabbitMQ, but under this kind of scenarios we ran into that we felt a lot of pain. And talking with other users of RabbitMQ at certain levels of scale, they kind of have shared similar thoughts. But when you have a very loud producer, so you have concept of a producer, something that puts something on RabbitMQ, a queue, or an exchange that writes to a queue, and then a consumer. Under scenarios where you have a lot of data, the consumer could actually get blocked on the producer's writes. And so how this kind of manifests is you're writing in a lot of data onto an exchange, and the queue, the consumer on the queue that might be part of that exchange, is actually unable to keep up with processing data. And it's the only way to kind of solve this is like we do some kind of magic with our service discovery where we essentially like move an entire pod out of commission so that it can essentially catch up, and we might bring in kind of net new pods into our infrastructure. So Kafka has yet to run into that same issue because of its write patterns and read patterns. Obviously, there's totally different load patterns and kind of scale intricacies of Kafka that I'm sure a lot of people talk about more recently. But so far, and I'm a technology hater, I feel like there's a lot of stuff out there, and on a long enough timeline, all software is terrible. But I'm actually really pleasantly surprised by Kafka in its improvement for kind of our use case, at least, of kind of having a stream of time series data essentially that we're processing.
And in terms of the analysis and determining when to alert your users, I'm wondering how you determine when something is a potential threat, or whether you have any sources of data that you use to create these signatures of what an attack might look like, particularly given the continually evolving landscape of security threats and new types of attacks.
We don't use signatures, and that's always been something we talk about a lot, is that we're essentially kind of behavior based, right? Like identifying maybe risky behaviors that could lead to a breach. The goal being is you obviously can identify it before it happens, but yeah, you're right. There's definitely an evolving landscape of kind of threats out there, advanced persistent threats, or
mediocre. There's some mediocre persistent threats too. So it's really based on, so we have a set of rules that based on some of the data that we'll get out of Audit D, right? So you could write a rule that, let's say that you set up a user that let's say that you set up a honeypot, right? So there's a machine that has a user with a known weak password. You could, set up an alert in ThreatStack that says, anything that this user does, just alert me on it, right? We ship a bunch of alerts out of the box, and then we work with you to kind of customize, what makes sense for your environment, and how does your workload run?
That's actually a really good point, which is for some companies running Nginx, for example, that's normal, right? That's their maybe web server or reverse proxy they're using. But for other companies, if they saw Nginx running, that could actually indicate a breach or a threat, right? For some companies, running Netcat is not great. But Netcat is a really powerful tool for debugging kind of network connections. So,
one of my favorite rules that I'm kind of writing right now is like certain classes of servers should not be running GCC like ever, right?
Yeah,
that would be an indicator of compromise to me, right? So for any of the compiler tools like on certain servers, like that just should be a sub 1, because that means somebody is trying to maybe do like a proof of concept exploit or something like that. So I kind of focus more on the rule sets as like, these are things that I don't want to see happen in my environment, or I know that they happen and I want to suppress certain types of them, and everything else I'm concerned about. So it's not signature based, which is nice. It's just based on, we have some basic rules for tools that are typically associated with exploits and stuff like that.
But also a really basic rule if you're trying to identify for data exfiltration, for again, Linux is what we're talking about. There are usually only so many ways to get data off of a Linux server. And so if we basically look for those processes and we start seeing usage of various tools that could exfiltrate data, we can...
Or even just connections outside my...
IP range, yeah, exactly.
My LAN, right? That's probably bad too. So there's a whole way that you can start to customize and think about how these things. One of my favorite ones is in the one that I use as my biggest input to the security program is sudo. I want to see when people are doing privilege escalation. I want to see what they're doing, when they're doing it, why they're doing it. And I alert on those because I want to find ways to reduce that, right? So
it turns into a good way of identifying potential manual events happening in your environment. We did a webinar with a customer quite a while ago, and the way they actually used ThreatStack was interesting in that it was a company that had been around for a very long time. And so just like most companies, you have turnover. The people who maybe created the thing are no longer there. And it allowed them to kind of bubble up this visibility around operational manual tasks that were going on in their environment, like user edits a file, restarts a service. They don't tell anyone they did it because it's something they've been doing forever, but it's happening. It's not visible. No one knows that this is actually something. The term I think that was popularized in the Google SRE book is toil, right? It's a thing you spend time on that is not moving the business forward, right? So it's kind of identifying those scenarios as well is pretty helpful.
Well, and you think about, is ThreatStack finding, all of these threats across all these infrastructure, all these customers? And, yes. But I think the more interesting output of ThreatStack is what are people doing with infrastructure that maybe we need to optimize for, right? Companies have said, oh, we have a CI system. We know that our code is being deployed in this particular way. And then they install ThreatStack and it's well, actually, Sam logs in and SCPs a file over to deploy that app because the CI system's been broken for, X amount of weeks, right? So it's that visibility, and it's not necessarily, vulnerabilities. It's just breakdowns in process, and I have this whole thing that I've thought about for a while that's good operations tends to lead to good security, right? If you're doing all of the good operation stuff, you have made it sufficiently more difficult for an adversary to do something bad, right? If you're doing regular patching, if you're doing limiting sudo access, you're probably in a better spot than a large percentage of other people, and adversaries are going to go for an easy target.
Yeah, it's kind of the old world of, and this is very 90s or early aughts, right? Of you get root, right? It was all about getting root. That was the old school hacker days. Because if you got root on a host, you probably got mail server, file server, DNS server. If you got root on one server, you probably had access to a lot of stuff. In the current model, and even in a lot of ways the future model, this gets more challenging on both sides. You have tools like Kubernetes where you're scheduling processes to run across a series of hosts. And so what container is doing which file system activities or network connections and things like that. And it ran on host A, last second, but then it got scheduled again and it ran on host D. And so, how do you get visibility kind of into that world? And, it's something that it's always fun at ThreatStack because we're, trying to see how people kind of do their operations in order to, help make it easier to get that visibility. What is actually going on? Who is doing these things? And how can we, maybe not do that anymore?
That's my job.
And what are some of the most common types of vulnerabilities that you've noticed in customer environments?
I kind of go back to what we just said. It's less vulnerabilities, though. I have seen the The example that I gave at the beginning, where it was kind of like, yeah, your web server is running Bash all of a sudden and running PSAUX, right? Like that seems weird. So that just kind of comes to my mind naturally as something that I've seen before. But also, it's mostly the breakdown of people and process. It's not necessarily like one single vulnerability, or I look at all the data and you say something like, oh, a bunch of people are running this version of Linux. That's not quite what I focus on. I'm more interested in the behaviors of users and how they're using infrastructure.
It's interesting too, because the most likely place you're going to get hacked is via probably email. And the outcome of that is probably someone paying an invoice to someone they shouldn't pay an invoice to. Actually, a friend of mine just told me the other day about how they got basically a breach. I guess you'd call it a breach, where someone paid an invoice that was from a scammer. So those I think are pretty often the case. What I think is interesting, especially in this kind of cloud world, is you hear a lot of people talk about, kind of immutable infrastructure, the great and glorious world where, you pre-build your images in advance and you deploy them and they never change in production. It's that never change in production part that I always find to be kind of funny, because and I actually had a conversation with some operations folks on that one. I was spending some time doing some testing around kind of in-place kernel updates. There was, as many people know, vulnerabilities in the Linux kernel. We want to patch those vulnerabilities by updating the kernel. And I was spending a good amount of time testing this because we have a lot of databases, and these databases have a lot of data. There's a cost of everything in Amazon. So it is not financially viable to say, I'm going to roll up an entirely new Cassandra cluster and copy over a few hundred terabytes of data. Because there's a cost to running two clusters. There's a cost of copying that data. It all costs money and time as well. But the response from this engineer was like, oh, well, like at previous company, we just used to build AMIs with the new version of everything. And I was like, yeah, we do that here. And then for systems that are easy to roll, like stateless systems, like roll the new host, roll out the old host, call it a day. But the thing that I worry about most often is, people build those AMIs with the latest, especially cloud native type companies, with the latest bits. They deploy them out and they run for a period of time. And maybe they're not doing something just as simple as enabling nightly security updates, which then take the latest update. And there's two schools of thought on something as simple as kind of nightly security updates. Maybe on one hand, you want to deploy updated versions of your OS software at the same time as you do a software deploy, that's great. Test it in dev, push it all in one batch. I think that's a great idea. But the other way is that, I would rather take the latest version of whatever's coming out in, specifically, let's say like Ubuntu, security updates, or, CentOS security updates. I'd rather take the most recent version of all of those whenever they're available, just to try to stay kind of one step ahead and and really just not have to think about like, what is my patch management strategy? I can let kind of the OS take care of it.
And in terms of the data infrastructure or the anomaly detection mechanisms, or even just the business aspects of growing and managing the business, what have you found to be the most challenging aspects, whether in the past, current, or that you're facing going forward?
So I'll give my most challenging. I think the most challenging, honestly, is really around the people side. It's for any company growing and scaling, the hardest part's always finding people. So and kind of finding the right people at the right time with the right experience. The challenge that we're dealing with is different in a lot of ways, and so we often tell people, when they come on board ThreatStack, it's like, oh, it takes a good 3 to 6 months to really kind of fully ramp up and get up to speed. And so often people are like, oh, like, yeah, I'll be up to speed in no time. And then when they start seeing like the scope of data and the amount of data and the fact that the data grows just exponentially every week there's more customers and there's more agents and there's more data. So you're kind of battling both, inherent change in scale, as well as just, well, there's some new features we want to push, things like that. Although Pat, I think, has probably the best example, which is have you ever recreated your software before, right?
Oh, yeah. Yeah, I mean, as we've grown, one of the things that we had to do is figure out how do we monitor ourselves with our own tool. And we were doing this for a while in a way that I would describe as not optimal. So, one of the things that we did was, we rebuilt ThreatStack in a new AWS account so that we could use it for monitoring, for testing, for kind of like a UA environment, but also, with my security hat on so that I have a environment that's stable, that I can understand what's going on inside the company, right? So rebuilding ThreatStack from scratch
which is it's funny too, because for kind of example, our development environment is hundreds of servers, and so when you think of yourself like you're a large SaaS platform, you're a hosted platform for customers, could you essentially from scratch rebuild that? Because oftentimes you build the first thing and they evolve over time, over many years maybe. And so like, could you go and start from scratch and rebuild it all again, right? Which it was a very interesting exercise.
It sure was.
And a lot of fun as well. I mean, it's always fun to go through those processes.
And what are some of the projects that you have planned going forward to improve your overall capacity or the feature set or capabilities in your infrastructure and in your product?
Yeah, no, that's a good question. So, we're constantly looking at how we kind of store and manage the wealth of data we have. For different databases, we use a lot of different databases, and it's not a bad thing because Postgres might be very good at handling some types of data, but Cassandra might be very good at handling other types. We've been playing around with databases like Druid, which we've heard a lot of good things about for kind of handling and processing data. Flink was the kind of the newest way in which we've been kind of toying around with how do we process data and manage it as well. But then just essentially it's very fun because we get to try things out very safely. We can we do a concept called dark shipping, where we might dark ship a new database or a new feature, where we can actually put it under production load for those terms and see how it reacts and run queries against it in ways that are not kind of impactful to our customers. And we can see like, well, this database is, the queries in this database is, a few hundred milliseconds. That's perfect. But in this other database, it's, thousands of milliseconds. Maybe that's not ideal for us. So there's always looking at different ways to store data and to also be able to do it cost effectively, whether that means, is S3 a great place to store data that maybe is infrequently accessed, or for things that are very infrequently accessed, things like Glacier, make it cost effective to store a lot of data. But yeah, for the most part, the nice thing is we're at a size where I usually like to use the term is we're just moving the ball down the field a little bit, and these slow kind of continual improvements in how we process data and what the infrastructure looks like, where Kafka's been a great success over the last year. We're going to be bringing in much more of it, and we want to, we like the durability and the failure patterns of it, and kind of investing more time there. And then even on the kind of operational side, improving some things like service discovery. We use Chef for configuration management, and as many people in the Chef community, you end up using like Chef Search, using the Chef server as a source of truth. We've been toying around with tools like Consul in order to store services and discover those. And even tools like Terraform. Terraform has a good community around it. We've decided to spend some time migrating from CloudFormation, which is great because it can help you build stuff on Amazon, but Terraform can actually help you build things on more than just Amazon, which is nice to kind of get that stuff into code somewhere. So it's really kind of just this interesting, slow, fun, iterative improvement on just how we get work done, for lack of a better word.
And are there any other topics that we should discuss before we start to close out the show?
That's a good question. I don't know. We went through a lot.
Yeah. I can't think of anything.
So for anybody who wants to follow the work that you're both up to and get in touch or keep up to date with ThreatStack, I'll have you add your preferred contact information to the show notes. And as a final question, I'm wondering if you can share your perspective on what you view as the biggest gap in the current tooling or technology for data management.
Yeah, I got one for this one. So I really like Kafka. I really like how reliable it is. I like everything about it except managing it. So when I think of like the command line tooling for, reassigning stuff, it's a lot of, pipe out this JSON and then edit this JSON. And
that's actually a really good point, which is the biggest gap is many databases are, I guess, they are designed operationally poorly. Good examples, as I can explain, like Spark. Involves like shuffling bits around and having like host files set up, and operationally it's not fun to manage. Cassandra equally as well, ways in which you have to define the ring it's defined via like IP address, which if you control your IP addresses in your own data center, then it's great. But if you're on the cloud and, this is like pre-elastic network interface, you may not control your IP addresses. And so how do you manage that? Yeah. But yeah, Pat brings up a great point, which is there are databases that I would say are very operationally friendly because maybe they have fantastic APIs. Like Elasticsearch has great APIs, and it makes it very, at least again, from my perspective as a longtime user of Elasticsearch, trivial to manage. But as a new person into Cassandra, when I started ThreatStack in 2014, and now Kafka, these are interesting in that they really lack good tools around them, at least at this point. So, if anyone of your listeners out there is building some new software for managing data, either build really good APIs so other people can create tools, or basically build good tools on top of it for like people to actually manage.
Yeah.
All right. Well, thank the both of you for taking the time out of your day to join me and talk about the work you're doing at ThreatStack. It's definitely an interesting problem space and an interesting solution. So I appreciate your time, and I hope you enjoy the rest of your day.
Yeah, thank you. You too, man.
Yeah, thanks for having us. This was awesome.